Hello, let me continue where I stopped last time. Now, please have a look at the picture I have here. Can you see? Now, we come to several, notice this, exotica. So, this one is a probably it is actually a kitchen and meat thermometer. Now, it is used extensively due to the big accuracy here. Let us say you wanted to make some other equipment which is a little sophisticated, but use a similar thing, you can always cannibalize all these items. It does not cost anything. The costliest thing costs maybe around in India, no, the equivalent around $20 US, that is around probably 2000 rupees, and I am sure if you look around you can get it cheaper. The important things you can notice here is, first thing is the display with the keys. If you want, you can use all the keys. You see here that some of the keys are not very useful, and the more important thing is this probe. In this case, probe, display, and at the back there is a device to hold the power supply. You can just open them, take pictures, make 1:1 things, and that you can use in any one of your other things. Let us say you wanted to make a temperature measurement device which measures the ambient temperature when you are around. You need not buy it, you have this, and all you have to do is just stick it out, let one part of it come out. And if you remember, I showed you the, I am not sure whether it is a Arduino board or that Beagle board or whatever it is. I said some part of it may be getting hot, I need a fan, and then I said I need a heat dissipator. So, when the heat dissipator, fan, everything is there, I can probably even disable this whole I am sorry, disassemble this whole probe and attach it to one of those things and get a signal somewhere and then try to utilize it for the first prototype model. For all this a little bit of jugglery, it is enough if you just start and then go ahead and start things. Now, coming back here, I glossed over a few of the things there. You need to make, as I said, a library of various components. A standard library will have probably just listing of all of the thing as a bill of materials. Now, we come to interesting things like this. You see in here, I am not very sure, to me it looks like an N connector, and I do not know if it is just a N socket and plug together, or one side it is N and the other side it is an RC or anything. If I have several of the devices taken from a catalog, followed, no, I have several of these devices taken from a catalog, I will see that when we talk about a N connector and when we talk about a TNC or we talk about a various type of things, only the interface standard is the main thing which is talked about, but the mechanical things vary a lot. Some of them, you have a flange here which is fitted to a panel, and the connection itself, some of them are just straight, some of them have a bayonet mount, meaning you press and you lock it inside. All these various details are not easy to pick out from a standard what do you call data given by the manufacturer. And even if you file all the drawings together, going through the file and looking for our thing, no, looks crazy. Instead, get the original if you can. If you can't get the original, make a drawing with all the 3 views including a 3D view, make a scale printout and keep the scale printout with you. Moment you take the scale printout with you with all the various things which are cut there, we can, instead of keeping the component there, you can keep them here and happily play a little bit of how to put the jigsaw puzzle. A jigsaw puzzle is made such that one piece does not go into the other piece, even if it goes, the whole scene will be wrong. So, you have a reference scene and you put inside. Symmetrical jigsaw puzzles, most of the pieces look same, however starting from 4 corners and some reference you can nest it. In our case, our jigsaw puzzle has multiple scenarios which it can project. I have a scenario in which some of the devices are in one corner, or I have just shown you one photovoltaic panel which is flexible. I have a flexible photovoltaic film. So, that flexible film can be either made like this, or it can go on top of it, or if I had shown you the remote control, why not have a photovoltaic device which is directly when you leave it on the outside of the table on a flat surface, it can happily, wait, my hearing aids, you can happily allow it to charge all the time. You have seen that what looked like a small photofilm is a full fledged flexible photovoltaic panel. Now, I have all the latitude available for me for rearranging all the things together, pieces of the original jigsaw in some other way by which results in a completely different product. The product may be generic, but my calling this at this instance, I can claim an IP on it. So, I am sure you too would have seen JBL charge to players and all that. There are any number of clones are available, but we know clone is not as good as the original, but at least in the picture things look same. So, it is with the 3 apples. I am sure all of you have heard about the 3 apples that change the thing. First apple in the Garden of Eden, and then the next 2 apples, I think all of you people know, the poor thing which fell on one of the scientists, and lastly one entrepreneur who changed the way we think about it. And you will be surprised, even when the first Apple computer was made, the whole thing was assembled together using foam core boards. The design was done like the same thing with HP, and eventually even now see a lot of mobile these things and applications, and if you have, can easily be simulated using your home printer, what you have at home. So, let me quit this thing and then try to get back a little deeper and see what I have here. Yeah, I think most of them I have covered. These are some things which we hate or hate to love. You cannot get rid of an equipment without a switch of some sort, and sadly neither these connectors. While there I spoke to you about a type N coaxial connector. These are the unfortunate connectors we end up with the computers, unfortunate connectors we end up with our phones, that is our 6 and 8 pin RJ series of connectors, and they occupy space. And while the connector interface itself, while the interface itself has been standardized, what goes in and the way it takes a turn and where it sits on the printed wiring board and how it jots out. Does it go into the printed circuit board, or does it go into the enclosure, and how is it wired? do we end up with all this funny type of wiring and this horribly colored stiff things coming everywhere, and then we have something else, and finally what about all this hardware? All this, of course, I also understand that works best if you have it actually in 3D, but getting it into a shape and getting it 3D printed in an economical way is not easy. So, I can go back to that 3D what do you call, I am sorry, printed thing now. See this here, something have you noticed? First of all, you are forced to keep the prints vertical, the layup process is vertical, and due to some unfortunate this thing, if you attempt to close all these things, and then you end up with the problem of how to either assemble the circuitry inside, or the printer usually has a build up material, and that a lot of time is required for you to release the holding and support material inside. So, what looks like a very automatic, very easy way of converting, why don't we just do 3D printing, why don't we just do laser cutting and all that, still has serious limitations, and all of them have the main final thing of having to design very, very carefully about it. While I have talked to you about it, now let me get back to this again, this sheet. You have seen this, it looks very neat. It goes in cute here and everything looks honky dowry. I do not know what it means, how do you pronounce it, pardon me for this thing, heavily accented. What you need is, you notice here there is a thickness of this material, and the thickness of this material seems to be critical in determining what is the depth of this cut. If the cut is more than the thickness of the material, it does not stain. Somewhere or other there will be interference, and if the depth here is not completely matched to this, you will have a item which is not as neat as it looks. It looks neat, that is all I can tell. In the hand it looks neat, but you see here, it does not really sit that well as we imagine it does. It does here intentionally, I mean my colleague is holding it, he has made it pop out, and sometimes we do the mistake of building a dovetail into it. You see the problem, let us say I try to make a dovetail. I think those of you who are typically woodworkers would have noticed how dovetail sometimes leads us to a problem. A dovetail works best if both of these are on the same plane. Otherwise, you cannot have effort to have a dovetail with only straight cuts. I can have a dovetail here. To match the dovetail here, this must have a slope here. So, you end up having to probably print these things separately, and this, as I said, I was trying to tell you about it. No, I have a dovetail here. So, one of these, usually the projecting part will have a taper this side. Now, corresponding to this I have to give a taper here. So, I have to make this equal to this width, and then afterward take it out and fit it manually, file it and try my best to fit it. Once the dovetail is in place, then the whole thing is stable. Right now this is not in a very stable state. If one of them is disturbed, the whole thing will pop out. For these things, still a little skill in model making, little skill in thinking forward is needed, and all things can best be done if first time you make something on a small scale, preferably with the resources you have here. So, we assume that all this nicely is centered Looks nice, is it not? We have something here, we have something here, a nightlight goes here and this thing. But first thing you will notice is things do not automatically center themselves. We would have ignored a thickness build up here, and this part may have got its datum referred to somewhere else, and the printed wiring board on which the components are mounted may have had a different datum. With this, usually on the z axis there will be an error, sometimes up to a thickness of one of these sheets. All these shortcomings can easily be worked out here, and even if you give a file to somebody and by the time it comes out, you will notice that there is a error and you will be thinking, oh, I missed it, and you are back. You would have sent your file, you got your job back, and then you will notice that, oh, I wish I noticed it then. Okay. Other option is, like what I have been suggesting, is make something out of, with your normal printer, put it on a cardboard, the whole thing, now pass it on to a next level of a serious hobby is to concentrate on packaging, or give it to the model maker who will understand what it is you wanted. So, if you look at my thing here, by experience I would like to tell you that this is a little recessed. We are feeling very pleased about it, that is a little recessed. Then we noticed that matching plug does not go into that opening, as a small something is blocking the way, because the interface has been made standard, but not the hardware, and that was made such that when it is flush or with a specified gap of 0.8 mm, everything sits comfortably inside. So, we had to redo the whole thing. So, it does take a little bit of time, and this of course is I expect the student was very keen on making a thorough job of it. So, I am a little happy, and he or she has gone to the thing saying, I will also give a rounded edge here because it is easy for me to do. So, I am happy now. This can easily be, probably you can take pictures of it and post it, and the other side manufacturer will easily fabricate a piece like this and get back to you. A near perfect fit, near perfect, okay. But while we are quite happy the way this whole thing has come from the shop, when we had to use it, we found that there is a small misalignment, and the trimmer tool, screwdriver or something what we had was not going in easily in that. So, then we thought, oh, I wish we made a hole bigger and so on like that. No, this thing can be sorted out at our level. Now, I will try to go up. This is the drawing of, I think it is a 2 by 20 backlighted LCD display. You can't really make out much by looking at the drawing. I know there are dimensions and added to it to, if it happens to be a generic drawing saying we have 2 or 3 variants in it, you will notice that sometimes we are expected to look here and then look at a table to see which variant is what is needed. So many of these things, and then so many stuff is there saying and so on. Imagine now, if we are to take a printout of this, make it 1 to 1, You understand, no? Take a printout, make it one to one, probably even laminate it and keep it along with your thing. Anytime you can move it around on your layout sheet and you know where we stand. So, the actual display is probably this one. Where is it? Where is it? Yeah. This is where I thought I will add the thing. So, if you can get an actual display or you can find out from an equivalent thing and you can make a, just make a copy of this, scale it if required, and very important feature is the alignment of the visible window to the, with respect to the mounting holes. If you have all these things, two things you can do. This whole thing can be used directly on your computer screen for arranging things. Later on, to be on the safe side, because we have two tabs here meant for soldering, and I am not very sure what is it at the thing. Most likely it is a driver which is sitting on the other side. This may be some power supply. This may be the thing which is required to connect a port to drive all these what do you call dot matrix display. So, even if you are to make the full thing in a full fledged 3D software, you need to input all these details, and our bad luck is if it is a generic display, you understand, no? You got it from one place which is generally, somebody will give you a compatible device. Compatible device often either the mounting holes are compatible or sometimes only it is an electrically compatible device, saying if you connect it to that particular card or another what you call display driver, it works. Mechanical things, there is always that small print on it, no? Improvements are possible, and we are continuously improving the product. When you try to continuously improve the product, first thing that goes for a toss is the dimensions. So, going out, you remember I just showed you that haha, I am here. I am not sure what exactly it is. It is probably that same thermometer. Why I am saying it is a thermometer is, you see here, this is the side of the case where it you know plugs in here, and then this whole thing is the top of it, and then most critical you have seen here, after everything is done, still there is a long cable here, because this particular probe probably needs a 4 wire measurement, and in the case of a 4, and then added to that it is a coaxial element. I do not know whether it is actually the tip of the probe, they have a p-n junction, or it is actually any of the thermocouples and so on, and this is where the display sits. You have seen that, no? And display is having 4 mounting holes. So, what looks like a very elegant nice product, once you open it, it is not, I can't say it is good or bad, but still it has a bit of uncertain things around. All these things can probably be made out easily. Now, you see here, this is a connector, and then we have a display, and then there is very thin this thing by, I do not know how it makes a contact, it goes and sits there, and the power is taken from there. Most important is, this is a very ancient way of and an inexpensive way of making buttons. See here we have 3, I am sorry 1, 2, 3, 4 contact arrangement. So, you have one either high and low or A and B, and then we have a elastomer contact, and the whole thing goes here. So, all this thing will probably be easiest if you can try to make things at best as you can. Once it is ready, then the mold maker or the plastic designer can improve on this. In this. So, we have something which is holding together, and I am sure what most of us hate is probably this spring and something very very unreliably which is put here, and then there is something else here, and then this plate. This is usually the positive has a dimple here, then the negative portion has this spring because a small variation possible, and this is the tricky part. That whole thing is supposed to go here simultaneously matching this display, these keys and all that. So, that obviously is a specialist, the packaging person's job. So, while these are very they call sold in large numbers at a low price, most of the projects which you do probably take care of this by taking a display from somewhere, and probably a keyboard and a generic they call a microcontroller type of a device, some generic power supply, arranging all the items together, and later on at the next stage now you can go to the person who makes these things. So, I think it is worth it if now have a look at this thing. Not easy, no? This big black blob is the actual processor which seems to do everything, including take a measurement of the device wherever the tip of it, and also parse the keys here saying what is it that the keys are asking you to do, and eventually display it, and it has other various other things and things which we do not like at all, like there is a buzzer here. There is no simple way of connecting that the buzzer to this. I showed you already. I will get back to it, nothing. This is the what I call the 3D printer what we have. I thought I will show you these things. These are typically RF and microwave devices. So, you will see here they to use special type of connectors. This is probably that SMA type of connectors, and we have these things. Another problem in these places here is the moment you are going at microwave frequencies, layout is extremely critical, and you end up with multiple antennas, and then in this you have so many of this, all this stuff which goes around like this, nothing, that is a load cell and somebody is trying to demonstrate. In this something which is very very interesting and important for you to note, especially if you are one of those electronic technical people, very carefully they have shown you a breadboard, probably it is the old wish breadboard, and saying on the breadboard you have this many interconnections and so on. You have a something which is shown here, I am not sure what it is, and there is a with a variable LED backlights, meaning you can increase and decrease the thing, and the most important thing is the whole thing is printed on a in this background is a school block book. So, you have a circuit diagram here, this is the main this thing. So, you can see probably VCC, ground and so on, and the whole thing is neatly. So, we have a basic schematic diagram converted into a working what you call circuit, and finally it is driving a display. And all these things in this case because this seems to be only on how to run the display, various types of sensors, inputs have not been shown here. The sensors and inputs and intercommunication to the outside world and all that have not been shown here. So, this is how exactly our things go on. Now, I will get back to a real life product. So, what could this be? I am sure you may have seen this at various shopping places. This of course is taken from the display person's thing. So, you have as part of any product, obviously you have all this, and it is not your business. Your business is only trying to make the display. In this case, it looks like the customer end display attached to a cash register or something. These things are very easy for you to go ahead and try to make a first model, and then go and you can make a presentation to somebody, and you can probably get going. And if you are and if the time for idea has come right, you can make a unique product which has your own IP, and probably you can get a design registration and make a presentation to somebody who will take you to the next level, because finally everything involves scale and everything involves a niche. So, if you find a niche and you can find that your product fits into this, before you commit huge amount of resources by way of all that those things I do, or make a very crude thing saying I have all this in a shoebox and then I will show you, not many people will be impressed by it. So, I wish you that you get into this. I will stop this particular presentation this time at this point. We will go on to a new topic next time. So, thank you.